Okay, so again, you've seen this before. We have a trig function of an inverse trig function and with some kind of input. The only difference this time versus last time is now, instead of one variable, we got two variables in there, okay? And I told you both of those variables are positive, okay? So we're supposed to write this as an algebraic expression. And both of you, looks like you did the thing. You say, well, let's let theta, because arcsine or arctan or any of the inverse functions you can think of, their outputs are angles. We think of angles as theta, phi, alpha, beta. And so it's going to help us get into the right mindset if we do this. Let's let theta equal arcsine. X over y. So what does that mean in terms of, like, now what do? What's the thing that we do?
Sine of both sides.
Sine of both sides, right? We take sine of both sides. That gives me sine theta. Gives me that. And we're assuming that x over y is in the domain, okay? Like otherwise none of this makes sense. We're assuming that x over y is in this domain here. Otherwise, whatever, right? So maybe I could have said that there, whatever, doesn't matter. Doesn't matter, like, we know this game that we're playing. If I don't say something explicitly, assume that everything works out, right? So taking sine of arcsine is the thing that undoes that. That's why we did it in the first place. So on one hand, sine theta is equal to x over y. But on the other hand, in terms of triangles, sine is equal to what over what?
Opposite over hypotenuse.
Opposite over hypotenuse. Don't mess this up. I guarantee this is gonna be on the quiz. Something just like this. In fact, it's going to be
like a
so similar to this. Yeah, it might be a smiley face over like a middle finger or something. Sorry. Okay, and so we're going to set up a triangle. We're going to set up a triangle that satisfies this. Okay, so here's theta. You could put your theta up here. You could draw it like this if you're so inclined, and put your theta here, put your theta here.
The right angle.
The theta can't be the right angle. That's the only restriction you got, okay? So let's get the sides. What sides do we know? Do we know this one?
Y. Wait, no. No.
We don't know that one yet. Do we know this one?
X.
That's X. And then that leaves only one option.
Y.
Y, right? Because if sine of theta is x over y, it's got to be sine is opposite over hypotenuse and so on and so forth, which means that this is what?
Root x squared minus y.
And you would be so wrong, and I would not give you
Y
any.
squared minus x squared.
Y squared minus x squared. I would not forgive you on a quiz if you made that mistake, because I guarantee that you didn't do the one thing that you should do, which is this. Because you're gonna make the mistake if you don't, right? This is what this is, right? And so there we take the positive square root so that we get this right there. Don't just think, oh, it's that one minus that one. Like, just check yourself, because I'm telling you, I will not forgive you. I'm not going to be nice about this right here, setting up this triangle. Okay? Is this triangle correct? Or have we set it up right?
Yeah.
As far as I know, that's good. Sine of theta is indeed x over y. And so now, our problem reduces down to what is tan of theta. What's tan theta?
X over the square root of y squared minus x squared.
Opposite over adjacent, right? And so we got this right here. There you go. There is your algebraic expression in terms of x and y. I didn't bother to write that. In terms of x and y. Algebraic expression of x and y of that thing, right? Now, some other interesting questions we could ask would be like, what restrictions do we have on this? Could do something like that. I probably won't do that to you though. But that's just something to note. Like, oftentimes when something like this comes up in a problem that you're working on, that's like the next thing you have to do is like, well, wait a minute, hold up. Can I just plug in any old y and any old x? No, if they're equal to each other, we're going to have division by 0, and that's going to be a problem. So we need to kind of figure that out.
If
Especially
x is bigger than y.
If x is bigger than y, you're going to have a problem.
Which makes sense in the top one, because then
If x is bigger than y, what happens?
it's bigger than 1.
Oh, interesting. And so, yeah, these are the kind of things you have to worry about. Okay, so that's a good one. Another thing, so we're gonna, like I said, next time we meet, whenever that is, Because again, I don't have a schedule on my fridge. And my fridge is where I get all of my information. And if it's not on the fridge, I am not in good shape. So, the next time we meet, we're gonna have a quiz. You're gonna have a question like that. You're also gonna have a question like this. I'm just gonna make one up. How about this? Let f of x equal. Let's do, how about okay. Find the domain and range of f. What's the domain?
One. Well,
-1, no, 0 to
Zero.
1, but then, yeah, 0 to 1.
No.
Oh, wait. Oh, negative
negative.
pi over 2,
I'm asking for the domain.
Yeah.
What inputs can we put into this guy?
negative pi over 2. Oh, wait.
-1 to 1.
Yeah.
Oh,
This guy. This is input. This is the first thing we have to take care of. Maybe we'll have something else we have to take care of in a second. But the very first thing we need to look at is this thing. Arc cosine only takes numbers between -1 and 1. And then it puts out numbers from 0 up to pi. And is there any problem with sine taking numbers from 0 to pi?
No.
yeah. You can't, it can't equal, for the, not for the domain.
Yeah, not for the domain.
Yeah, not for,
No problems with the domain here. Okay? Like, as far as we're concerned, as long as we stay between 0 and 1, we'll have outputs which go into sine. And what can go into sine? What's the domain of sine?
all in.
All real numbers. So we don't really have to worry at that point. Okay? So the domain is what?
-1 to 1.
1. Hard bracket.
Inclusive. Yes. Yeah, it's the range. So let's think about this. As we go from, let's just go through the domain. We start here, we plug in a pi. What happens to sine when we plug in a pi? In fact, it might be nice, if you have a question like this, to just go ahead and do a quick thumbnail sketch of sine. You know that you got pi over 2 here, you know you got pi here. Okay? Now notice what's going in. It doesn't matter which direction they're going. And as you go from -1 to 1, it's going from pi to here. But we only care about output values. So what output, if I put this, because think about what's happening here. Okay, we're taking x and we're mapping the interval from from -1 up to 1 gets mapped into this thing by arc cosine into the interval 0 up to pi. Now we're going to take that and throw that into sine. And what's going to happen to that interval? If we throw in everything from 0 to pi, what outputs are we going to get?
Everything from 0 to 1. -1 to 1.
From
Oh,
negative
wait,
1?
no, from 0, yeah, 0 to 1.
Yeah, see? You're not going to get to your -1s because you're not going far enough over.
Yeah.
And so, as you throw in 0 to pi, what pops out of sine is everything from 0 up to 1. And so the range would be from 0 to 1. You're definitely going to have a problem with this. You're definitely going to see this. Okay? And it might even be way uglier, like this. It might even be... Oh, did everybody get that? Too late? Okay. All right, let's do... Okay. How did I want to do it? I wanted to do it that way. I wanted to go... This is what I wanted to do. Oh, man. All right. Oh, man. This one's hard. This one's really hard. What's my domain?
Arctan can have anything.
Arctan can have anything.
And sine.
But can arcsine have anything?
Arcsine is.
Only from -1 to 1.
Ooh.
So our domain's just negative.
It might help us out to draw arctan.
Yeah.
Okay, the biggest output that actually never gets reached is pi over 2. The smallest output that actually never gets reached is negative pi over 2. And so, we are going to need to restrict. We can't plug in stuff that's going to get us next to pi over 2 because we cannot plug that into arcsine, right? Like if I plug in something really big like 100, we're going to get something really close to pi over 2. But then if I try to plug that in, arcsine of, I take arctangent and it gives me something really close to pi over 2, so it's approximately pi over 2. That's too big. I cannot plug that into arcsine. So I'm going to need to restrict the outputs because we know that arcsine only takes values between what and what?
-1 and 1.
And so we're going to need to restrict it so that all we get is stuff from -1 all the way up to 1. How do I do that? What value here is going to make that happen?
Oh.
In other words, I plug in something into arctan and out pops a 1. Or,
And
okay, you plug something into tan. In other words, what do you plug into tangent in order to get out a 1? Tangent of what equals 1?
pi over 4.
Pi over 4. Okay. Oh wait,
Right?
what did I just do?
Wait, no, when you plug in.
Yeah. When you plug in a pi over 4, you get out a 1.
Yeah.
Ooh.
Oh.
So how do we do this?
Uh,
It would have to be when I plug in a 1
Oh,
into
yeah.
tan,
What do you-
I get
yeah.
out a what?
Tan of 1. We don't know what
Tan of 1. Yeah, like I said, this one's really hard. This one's really hard. This would have to be tan of 1. And this would have to be tan of what?
Negative.
Yeah. Ooh.
Wait.
Yeah. I'm not going to do that to you. It won't be this bad.
Wait.
But I'm just like, but this is how you'd reason this out. And so you'd say, well, then the domain, the allowable inputs that will give you outputs from -1 up to 1, right? Because that's what you're looking for. In other words, what you want to do, you know that arcsine can take an interval. Now this is an abuse of notation. We don't actually do this. We know that we could plug in all this stuff into there. And so now we're asking what outputs of this thing are going to give me that. Well, it would be everything from tan of -1 to tan of 1 inclusive.
What if we just like turned it into an algebraic thing at the start and then found the domain of that?
That's maybe. We could try that. But first off, now that I've done that, what's my range?
Oh.
So now we know that we're plugging in the correct values that will give me this right here. And as arcsine goes from -1 to 1, what are my output values?
Negative pi over 2 to pi.
There you go. Inclusive
Yes.
on both sides?
Oh. Yes?
Yes.
Yeah.
I'm just testing you, right? That's really hard. I won't make you do that. I might make you. But I won't. That's a bit too rough. But you see what we had to do, right? We had to restrict. And think about how we got the inverse functions in the first place. We had to restrict the range, right? Because otherwise it starts, well, this is a similar thing. You can't just plug in anything into arcsine, so you're going to have to restrict it so that that happens, right?
Yeah.
So, okay, that's a bit too difficult. Now, a couple things I want to say. In fact, I'm going to do this in reverse order how I wanted to, because, just because. Yeah, that's the one I'm talking about. Here's a question from, not your very last homework, but from a homework before that. I want to bring this up because you'll certainly see something like this. So, find all the x in the interval 0 up to 2 pi, satisfying this. Cosine x times 15 cosine x plus 4 equals 3. Okay? Now, I may or may not write it like this, but ultimately you're going to have some kind of quadratic with a trig function. Okay? And this is the key here. Find all the x in this interval.
Yeah.
Find them, all of them in this interval, not one or two. There might be more than one or two. We're going to go through this, and I'm going to show you some pitfalls, okay? And I did not take off on you guys' homework for this because I did not explicitly state it when we did these examples. So, but for the quiz, I will expect you to find all of these bad boys. So, what do we do with this?
Multiply it out.
Multiply it out, turn it into a quadratic. It gives me 15 cosine squared x plus 4 cosine x equals 3. That doesn't help me. I bring the 3 over to the other side like this because now I know how to deal with a quadratic like that. Okay? And now I'm going to make a substitution.
Cosine effect.
I'm going to, yeah. Let's let a equal cosine of x. So then this reduces down to 15a squared plus 4a minus 3 equals 0. And now what do we do?
Quadratic.
Quadratic. So that a equals, how about negative 4 plus or minus? 4 squared is 16 minus 4 times a times c. 4 times 15.
Negative 40.
What?
Wait.
45.
Yeah.
Okay,
No,
but
30.
hold up.
60.
Hold up. This is 60 times 3,
180.
180. But it's negative, so it's a negative, negative is a positive.
Okay.
Yeah?
Yeah.
Right? So 4, and I have to make sure this. 4 times A times C. Yes. Okay? So that's the 63, 180. Okay. Negative, negative is positive. Okay. All over 2 times that is 30.
Was this one on the...
Yeah.
This one was on the homework. Now, 16 plus 180 is 196.
So, which is, I think, 14.
I think you're right. 196, and let's just see. 14 times 14. 6 and a 1 and a 4 and a 5 and a 4 and a 1. 196. Yes. So we have that A is equal to negative 4 plus or minus, what did we just say? 14 all over 30. Now, okay. This happens to be ones that we can actually compute. It may or may not be easier to just go ahead and compute them. I'm going to do it. It may not be necessary, but at any rate, I'm just going to do both of them. So on one hand, minus 4 minus 14 is minus 18. Yeah? Check me on that.
Yeah.
Okay, that's the same thing as 2 times 9 and 9 times, no, it's not a 9 times anything. 2 times what, 15?
But then 3 is also
2 times 3 times 3, 2 times 3 times 5.
3/5.
3/5. Everybody buy that?
Yeah.
Did I do it right? Okay, so negative, that was a negative, so that's negative, negative, negative 3/5. A equals, now what?
Add it. So it's
Add it, and we get
18.
10 30ths.
10 30ths, which is 1/3. Okay. So, but that's not the case, right? We don't care about A. We care that A equals cosine X. So, cosine X is equal to either negative 3/5 or cosine X is equal to 1/3. So now what do we do?
Arco.
we take the arc cosine, inverse cosine of both sides. That gives me this x is equal to arc cos negative 3/5. Is that legal? Can I do that?
Yeah.
Negative 3/5 is between -1 and 0, so we're good. I do that over here, I get x is equal to arc cos 1/3. Is that legal?
Yeah.
Okay, am I done?
Have we found all the x's?
Yeah.
Wait, we need the interval. 0
We are not done.
Uh,
All of them. All of them. We're missing 2. While these 2 are correct, that's only half the story. And this is what I suggest you do. So that, because at this point, especially when you're taking a quiz, you're going to say, okay, I got everything. I'm done. I've done the algorithm, and I've gotten to the end where now I have x by itself. But this is trig. Think about what this means right here. You know what cosine x looks like on this interval, right? Cosine x looks like this, right? From 0 up to 2 pi. And if cosine x is equal to negative 3/5, here's negative 3/5. Oh, look at that. We get 2 outputs. Here's one of them. Here's the other. So let me go ahead and I'm going to call this x1. I'm going to call this one x2.
2 pi minus.
yeah.
So, yeah, let's look at this. The negative 3/5 gives you which one of these? The first one. So there's your x1. Now, how do we get x2?
2 pi minus
2 pi minus that. Let's call that x3. x3 is 2 pi minus x1, which is arc cos negative 3/5. There's your other answer. Now, this guy right here, cosine x is equal to 1/3, lives up here, and we're going to get 2 answers. One's going to pop out right here, and one's going to pop out right here. Which one is this one?
the x2.
That's your actual x2, right? Because if you think about what does cosine pull back? He pulls back, arc cosine pulls back these guys right here, right? And so whenever you're plugging something into arc cos, these are the ones you're going to get. Those are the ones that come out. But you cannot forget about the other guys. And so this one, we're going to call him x4, and how do I find him? x4 is equal to?
2 pi minus x2.
2 pi minus it. And in this case, it's arc cos 1/3. There you go. So careful with that.
Yeah,
I know. And I didn't make a big fuss about this, so I gave you your points back. But this is a big thing, okay? I always suggest, and I don't think I said this, but I always suggest that once you get down to here, actually draw something out. Especially if you're trying to find all on a given interval. Go ahead and draw this out. It will help you so that you don't miss anything. Because if you don't have the bigger picture in mind of what's going on, like you're going to say, well, I'm done. I found what that equals. But let's not forget the bigger picture. We're talking, there's infinitely many possibilities. If I told you 0 to 4 pi, we'd have to extend this out to here, and then we'd see that we'd end up with another 4.
Yeah.
Right, we'd have a total of 8, and so on and so forth, right? So,
And you could just add 2 pi though.
you could. And on a quiz, I would be perfectly happy with you giving me these guys and then just saying like plus 2 pi, blah, blah, blah. Like you could say, for the other ones, if we were trying to find all 8, you could say then x5 equals x1 plus 2 pi, x6 equals x2 plus 2 pi, and so on. I would be perfectly fine with that. Okay, so this is the really, really mean thing that I'm going to do to you. So, the thing is, I'm going to have you do something that you, on the quiz, you're going to have to do something that you will not have had homework on. Which means you're going to have to figure this out on your own.
Is it like a word problem?
No. We're going to go through it.
Oh.
Then, I'm not just going to say, figure out the Riemann hypothesis, and then you just have to go puzzle over that. No. This is something, it's just that you're not going to have feedback on it, but it's, what we're about to do, it's going to synthesize everything that we did in graphing and everything that we've done in, with the inverse trig functions, okay? And so it's really, you're just putting stuff together, but just note that since you're not going to have homework on it, I'm not going to be a real jerk when grading it. I'll be nice, okay? But
Take careful notes.
take careful notes and practice, like come up with stuff, like actually work on this and see, and then like check yourself, okay? So, that's what I want to do first. So, one thing I will say on the quiz, you will have to graph 2 full periods. I'm going to give you a function and say graph 2 full periods of this thing, labeling the y-intercept, all the maxima and all the minima. You know what the maxima and the minima are, right? The maximum values and the minimum values. So, in other words, well, we'll go through it. We'll do that. But then, I'm going to do something really boring. I'm going to tell you not only to do that, but find all the zeros. Yeah, it's going to be rough. And this is what you're going to do. However, I think I'm going to be nice. I'm going to, instead of telling you to do 2 full periods, it's going to be something like this. This is what you're going to have on the quiz. Draw 1 full period. I'm going to say label all intercepts. And I mean y and x for this guy, okay? Now, this is the thing I'm going to give you. And this one's going to look terrible, but it's really not that bad. So here we go. Y equals pi times cosine x plus pi over 2 minus square root of 2. Now,
That's not bad.
if this were a 3 and this were a 1, you wouldn't freak out, right? Like if this were 3, you'd know exactly what to do. If this were a 1, you'd know exactly what to do. You'll notice how close this is to 3 and how close that is to 1. Okay? So let's do it the way that we know how to do it. On one hand now, this ain't so bad, is it? Like if there were a 4 in front of here, we have to figure out the stretching and the compressing and all that good stuff. But in this case, we really don't. Like, if you wanted to, you could go
That's just
x
the same
plus
as-
pi over 2, and then find your period, right? Like this. Just the same way we've been doing. So negative pi over 2, less than or equal to x, less than, that's 4 pi over 2. Minus 1 would be, what, 3 pi over 2? You could say the period is 2 pi divided by 1. So a quarter of that's going to be pi over 2. And so you just start here and count by pi's over 2, right? Or you notice like this is very much just like cosine has just been shifted in which direction?
Left. So
It's been
it's like,
shifted left by pi over 2.
like upside down the sign.
Either way you want to do it, it's going to work. And yes, it's upside down sign. And so let's go ahead and start there. 1 full period. And so normally he starts here. He's been shifted over by pi over 2, which means he must go through here, right? Comes down, comes back up like that.
It's only
And so-
1 0. We don't have to label them.
Amplitude is
Negative pi over 2, 0, pi over 2. So, 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Notice what I'm doing. I'm counting by quarters of a period, right? I'm starting on the left-hand side, counting by quarters of a period. One of you did something like this once. It was like pi over 2, 2 pi over 2, 4 pi over 2, 5 pi over 2. And it took me forever to figure out what had gone wrong. And I was like, how did you, wait, but you did the, and it's just, you didn't get all the way there. Yeah, okay. So, be careful with that, because I make the same mistake, right? These are very common mistakes. Now, if this were just regular old cosine x plus pi over 2, we'd say this goes from 1 down to negative 1. But in this case, it's pi times it, so it goes up to what? And down to what?
negative pi.
Okay. Now we just need to shift this guy.
Oh, I forgot.
Yeah, you forgot about that. You're like, oh, that's easy. Those are easy zeros to find. It's not going to be easy. This is my class, okay? So, now we've gotten that part. Let's think about this. Is that in magnitude, is that bigger than pi?
No.
No. So he's not going to come down that much. We could draw this qualitatively by shifting him down some, okay? And so let's start there. I'm going to go right here. I'm just going to shift it down some. And notice I said 1 full period. So this should be sufficient, okay? So, okay. I'm going to draw it like this. And I'm going to look. If I brought that down, this bit is going to cross somewhere over here. This bit's going to cross somewhere over here. So why don't I go ahead and start with my negative pi over 2, 0, 1 pi over 2, 2 pi's over 2, 3 pi's over 2. Now that's still the max, right? The maxes still occur here and here. And so they've just been shifted down. The min still occurs here. There's no difference there. Here, okay? And so I'm just going to draw it like this. And what did I say? This guy's going to have to come through over here. Okay? So make sure you don't mess this up and you start drawing it out like this. Like, right? We got to be careful of that. So he's going to come down, hits his min here. That comes down, so he's going to come back up through over here. Okay? Now, what's the high part? What is the output, the high part?
Pi minus root 2.
There you go, pi minus root 2. And if you're wondering about that, you could always just do this. What's the biggest cosine ever gets? The very biggest is 1. So if I take 1 times pi minus root 2, well, you're at there, right? What's the smallest that cosine ever gets?
Negative.
-1. -1 times pi is negative pi. Then you take it and minus root 2. Or you could just think about what you've done is you've taken all of these values and minused off root 2. However you like to think about it. Now we have 3 things we need to find. We have an intercept here. We have an intercept here. And this one's going to be the easy one. How do we find that guy?
Just plug in a 0.
Let's plug in a 0. Okay? So let's do it. We have pi times cosine 0 plus pi over 2 is just pi over 2. Minus pi over 2. What's cosine of pi over 2?
0.
So help me, if you write this right there, I'm going to be so angry. Okay? Like this, you know what this is. Anytime you have a sine or a cosine or any of them that's, say, over a 3, and you have any, something like that, you had better evaluate what it is. Okay? If it's over a 2, you'd better evaluate what it is. If it's over a 4, you'd better evaluate what it is. And if it's over a 6, so help me, you had better evaluate what it is. Okay? Everybody got that? So, can we evaluate cosine of pi over 2? Yes, we can. It's equal to what?
0.
So pi times 0 minus root 2 equals what?
Minus root 2.
Does that agree with what my picture looks like?
Yeah, because it was
It's
a
a
0.
negative, and it's a negative number,
Oh.
right? Negative number, so it should come down here. There's negative root 2. Now, what about these guys?
Set it.
Set.
Set what equal to what?
Set.
First, like, the equation.
Set the equation itself.
Or, yeah, y. Plug in 0.
The y plug in a 0 for y, however you want to think about it. Okay? Now what do you do?
Solve for.
So add the pi over
Well,
2.
simple.
And the root 2.
So we have root 2 equals pi cosine this stuff. Now what do you do?
Divide by pi.
Divide by pi, and that gives me root 2 over pi equals cosine of stuff. Now what I suggest right now is you go ahead and do this. Let theta equal whatever stuff is inside. And we'll come back to that. Okay?
So then our
Now, like I've suggested before, once you have something like this, like, if you had this, is there any way to solve that?
For hard codes.
Oh, no, there's not. Because you can't
1,
take arc cosine.
negative 1. Does this ever happen? Does 3 intersect that guy?
No.
No. In this case, you have root 2 over pi.
Well, pi's bigger than
And pi is bigger than
So,
root 2.
yeah, it's just-
So it does work, but you can also see that what you've just done, you know that it's going to intersect, right? Like because we've done all of this work, and we can see, yes, there must be, at least in this interval, 2 values. That's what we're looking for, right? So, okay, and another thing to notice here is, so root 2 over pi is somewhere in here, root 2 over pi, and so I am expecting 2 values. I am expecting 2 output values here. Or input, well, you know what I mean, right? 2 solutions, okay? And so, yes, you're correct. What am I going to do? I'm going to take arc cosine of both sides. So that arc cos of root 2 over pi is equal to theta. Am I done?
No,
Get this
well,
up
theta is
to-
x plus pi.
Theta, okay, so that on one hand, we have that theta is actually, so we have arc cos root 2 over pi is equal to x plus pi over 2. So we're almost done. We can bring this guy over. Arc cos root 2 over pi minus pi over 2 is x. But am I done?
No, because there's another one.
There's another one, right? And this is like, you know, we know that there's 2 here, and if you think about it this way, this could really help you. Because you could say, well, there's my x1 right there. Or my theta 1, whatever, right? The other one, how do we find him?
Wait, 3 pi over 2 minus. Oh, wait. No.
Oh, see, this is the great thing about once you boil it down, just get cosine by itself. You don't have to think about any kind of pushing or stretching or shifting or anything like that. All that's taken care of. And that's really why I suggest to do this. That you say, wait, we're not worried about him now. We're just going to pretend we're regular old cosine theta. We know everything we need to know about cosine theta. So when I take the arc cosine of that, I get this one, and then how do I find that one?
2 pi.
2 pi minus that value. We're going to say x2 is 2 pi minus the x1. You'd better know how to find it if it's sine. We happen to do two cosines here where we're taking arc cosine. You better know how to do it for sine.
It's just the same.
It's not 2 pi minus it.
Oh, it's...
You're gonna have, that's
It's
why I
just
suggest
pi.
you draw, but we'll do this in a
Pi.
second. We'll do a sine in a minute. We'll do a sine in just a minute. Okay? So now, if that's the case, what do I need to write?
Just x2 equals 2 pi minus x1.
Yeah, really, I'm fine with that. So x2 equals 2 pi minus x1. If you want to be really cool, you could do this. But it's going to mess you up because there's a minus in there. Arc cos root 2 over pi minus pi over 2. So then, I mean, you could go 2 pi minus arc cos root 2 over pi plus pi over 2.
Then put them together.
Ugh.
Yeah.
But one thing you'll notice, well, yeah, it's fine. Okay, so those are those 2 values. And, you know, this is probably going to get really ugly as you're drawing all this out. And so all I want you to do is tell me which one's which. Is this x1 or is that x1?
Wait, x1 is the left one.
X1 should be the left one, right? Because think about it. Arc cosine of something minus pi over 2, that should be a negative value. Right? Because think about arc cosine. If you plug in a positive value, the output you get is less than negative 2, isn't it? There's arc cosine, right? You plug in some value that's less than 1, which this is less than 1, you get an output that's less than pi over 2. So this value is less than pi over 2. You subtract off of pi over 2, you should be over here. So we're going to have that somewhere on your paper, and then you label that as x1, so I know which one you're talking about. The other one's x2. We don't really need to justify. We could do the same kind of analysis here and figure out where he would be, but there you go. Okay. And another thing, I mean, if if you have time to check, you could say, well, another thing is since this is less than pi over 2, and you're subtracting off pi over 2, it can't go any further past negative pi over 2, right?
Oh, yeah.
Right? Because in other words, you're taking negative pi over 2 and you're adding something that's less than pi over 2. It's not going to quite get you to 0. He's going to live somewhere in here. So that checks out. I feel pretty confident about my answer. You're going to have one like this. Sorry. Figure it out. But you can see it's not like really you're just synthesizing everything you've done in these two sections, right? Or in the two chapters that we've been working on. You're graphing and stuff like that. You're also, using the inverse functions to find these values. I want to do one more example like this with a harder one. This one, we're going to do this whole thing. You're not going to see this on the quiz. Well, okay, you're going to see something like this on the quiz. But I'm not going to have you find the x values. But we're going to go ahead and find the x values, the zeros, just so we can have a little bit more practice, okay? But this is going to be what you see on your quiz right here. When I first write up, this is what you're going to have on your quiz. It'll say graph y equals 2 sine 2x minus pi over 2. Plus 1. Label the y-intercept. All mins. All maxes. Draw two full periods. That's what you're going to have on your quiz. Right now,
We've done this one.
yes, oh yeah, we've done this. This should just be review. The thing that's not review is the thing that's not going to be on your quiz, because when I make you do this on the quiz, it's just going to be with one period like we just did. But just to get some practice, we're going to do this. Label x-intercepts. Okay, so this ain't so bad. What do we want to start with when we have to graph one of these guys?
Period.
Let's do it. So what do I write?
2 amplitude.
Oh, the amplitude is 2.
I never asked for did I ask for the amplitude? Oh, yeah, that's another thing, right? The label, I want to say the range, right? So like, you show me on the y-axis, this is what we've done every single time we've graphed something.
Yeah.
It should go without saying that I want it, but I explicitly know I do want it, okay? So, but, I don't know, where do you want to start?
Wait, do we do a phase shift too?
I never asked for, did I ask for the phase shift and the amplitude?
Well,
But is
it'll
it
be helpful
applied?
to know the phase.
Okay.
Would it?
Sure, I guess, if you want to, yeah. How do you want to do it? You tell me.
We could just
I didn't ask for the
Let's just
amplitude.
find
I
the
didn't
period.
ask for the phase shift.
just find the period.
0 to pi.
0.
Greater than, no, less
It's
than or
greater
equal
than
to 2x
2x.
minus
There we
pi
go.
over 2.
That's what I'm hitting.
2 pi.
Up to what?
2.
2 pi.
Wait.
Oh, right. Wait.
But we're doing 2 full. Oh, wait, that's yeah.
Yeah.
Yeah, you'd better do that right? Because that's one full period of sine, right, happens from there to there. So now we need to figure out what inputs make that happen.
So add the
Add pi over 2 to both sides.
Divide by 2.
And then we divide by 2, but hold up. 2 pi is the same as 4 pi over 2, so you add one more and you have 5 pi over 2. Now we divide and we get pi over 4 less than or equal to x less than or equal to 5 pi over 4. Okay? Now, maybe let's find the period.
Take a quarter.
Period's what?
Counting
pi
by pi over
4 minus
8.
pi. So just 2 pi.
3 pi over.
Oh, no, 2 pi over 2. Oh, yeah, pi.
And so what's a quarter of that?
Pi over
Pi
4.
over 4.
Pi over 4. Okay. So, we're going to count by pi's over 4 from pi over 4 to 5 pi over 4. So, and I'm asking for 2 full periods. Of course I mean positive and negative. Don't continue stretching them out this way.
Or just do
Okay,
like 30
so
by
here's
1 million.
pi over 4. 1 pi over 4, 2 pi's over 4, 3 pi's over 4, 4 pi's over 4, 5 pi's over 4. I have 1, 2, 3, 4 of them. It did get me to my place, so I'm feeling good that I got this taken care of. Now, sign starts where?
Pi over
At
4.
0. At 0.
At 1, at negative
Zero.
1,
Yeah,
at
zero.
0. Now this is one of those things. If you're in the habit of doing it this way, okay? It ain't gonna start, you're gonna get something different, right? But what does sine do from that interval? He does this. And so you would have to take this picture and shift him over or whatever. Okay?
Yeah.
Yeah, so be careful. That's why I suggest that you use the canonical interval, right? The 0 to 2 pi for the sines and the cosines, the cosecants and the secants. And for
And
tangent, you do negative pi over 2 to pi over 2. And then for cotangent, you do what to what?
0 to pi.
0 to pi. Okay? That's why I suggest you do it this way. You want to do it your way? That's cool. So he's going to come up and hit a max here. He's going to come back down. He's going to hit a min here and then hit right there. Now the way that we've drawn this right now, he would go from 1 to 1, but he's actually going to go from what to what?
2 to negative.
So 2 to 2. Now we just need to take this guy and shift him. And why don't we go ahead and figure out the rest of these? Okay? Because I told you to do 2 full periods, so let's do one more. I walk back to 0, negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. Let's see, 1, 2, 3, 4 should do it. So he hits a min here, it's a 0 here, hits a max here, comes back down. Looks terrible, but whatever. Now, what I've drawn here, though, is to a sign of stuff. I've not shifted them yet. Now I'm going to add 1. So that's going to shift everybody up. And what's my range going to be?
3 to negative 1.
Yeah, 3 to
Okay. So, let's look at this. This thing is still going to be a min, right? He's still going to be a minimum. And he's going to come up by 1 bit. So he's going to end up right here at negative 1. The other guys are going to do something like that. Make sure, look at that. He had to come up by 1, so he's going to end right there, isn't he?
Yeah.
Yeah. This guy's going to have to go up by 1, so he's going to end right there. Goes up to 3, just like he told me, down to negative 1. Now, I said the mins and the maxes. I didn't ask about this. If you want, you can. I won't ask about this, right? You could find this point and this point and this point. Although, I mean, I suggest that you would have done this. And you could figure, I mean, it's right there on your paper. So if you needed that information, it's right there. But now let's label the maxes and the mins. Where does this one occur?
Pi over 2.
Pi over 2. Yeah, we could simplify it if you want. Pi over 2 because it was 2 pi over 4. The min occurs where?
Pi.
This one's labeled because I put a little dot here and there's a negative 1 right there, so we're good. We know where that occurs. What about this guy?
Negative 5.
Negative what?
5 is
Yeah.
Pi over what?
2.
2.
Okay, yeah, that's fine. I just didn't hear you. It's not always a test. I just didn't hear you. Okay. Okay. So that would be that right there. Would be a perfectly good answer on your test because I didn't bother to ask you about these points. Though it would be really cool if you do it this way. That way, if you do need that information, it's right there.
Yeah.
You know. But I didn't ask you to do that, so that's cool. All right. Now we're gonna label the x-intercepts. How do we do that?
Set it to 0.
Okay, I'm going to get rid of all this to give us some room. So we set y equal to 0. So that means what comes over and then what happens?
Minus the 1.
Minus the 1. So minus 1 equals 2 sine 2x minus pi over 2. Okay?
Divide by 2.
Divide by 2. Negative 1/2 equals sine of, and this is where I'm going to do that right there. Because that's not, otherwise, that's going to mess me up. I don't know about you, but it totally messed me up. Okay? Now I can think about this as just a regular old problem where I say, oh yeah, if this is just plain old sine theta, right? And I have a negative 1/2. So here's my theta input. There's sine theta. I expect that this is going to give me 2 of these bad boys right there. And so, what are they?
Arc sine of
Arc
negative
sine.
1/2.
Arc sine of negative 1/2 is equal to theta. What is arc sine of negative 1/2?
Arc sine of negative.
Negative.
Oh,
The positive.
pi over 4.
Pi.
Pi over 4. Negative pi over 4. Wait.
Here's a hint.
Wait. So sine is.
Sine of what gives you 1/2?
Oh, pi over 3. 6. Pi over 6.
It's the last one you guys said. 5 or 6. Okay. Okay. On the quiz, if you have something like this, you'd better tell me what it is. Okay. But that's not obviously pi over 6 is over here. So what are these?
Oh. Pi
Think
plus,
of reference angles.
pi plus.
This is pi over 6. This,
Looks like pi over 4.
how about 5 pi over 6, 7 pi over 6, and 11 pi over 6. Which ones give me the negative 1/2?
The bottom 2.
The bottom 2, right?
So 7.
So this one is at 7 pi over 6.
That's easier than I was.
This one is at 11 pi over 6. Okay? And then from there, we have multiples of 2 pi. We have those two. So, like I said, like this is, we have to synthesize everything we've done up until this point, right? 2 answers for that. One of them is 7 pi over 6. That looks like a 4, whatever. So theta is either equal to 7 pi over 6 plus 2 pi times n. Yep. Because we've shifted this guy, haven't we? How do we know which ones are which? This will make your life so much easier. Because you know that on this graph, if you just continue it out forever, that one repeats every 2 pi, right? And in both directions. This one, the other one, is 11 pi over 6 plus 2 pi n. But theta wasn't what we cared about. That's what we cared about. So we have 2x plus minus pi over 2 is equal to 7 pi over 6 plus 2 pi n. Now, this is a bit more involved than what you're going to see on the test, but this is coming. This is coming. So pay attention. We're good. You're going to be doing this till you're blue in the face. And I want you to see it now. I guarantee you're going to have a ton of these to do. Okay? So these are all the possible solutions. This is everywhere on the graph, both directions, where sine theta gives you minus 1/2. Now we've said, but it wasn't theta that we cared about, it's x that we care about. So now let's get the x by itself. Now, just real quick, if I had something like this, 2x plus 1 is equal to, how about 7 plus, how about 5x squared? If I subtract off the 1, do I subtract it from every single term?
No.
No, I just subtract the same type of thing from the same type of thing, right? Okay, and so if I've done that, now if I divide by 2, do I only divide by one of the things?
No.
Or do I divide everybody by 2?
Everybody.
Everybody, okay, so let's put that into practice here. When I add pi over 2 over to here, we have 7 pi over 6 plus pi over 2, which we can make a 6 that way, yeah?
Yeah. So 10 pi over 6.
10 pi over
5 pi
6, which is what?
5 pi over 3.
It's what?
5 pi over 3.
5 pi over 3.
Yeah.
I'll buy that. Plus 2 pi n is 2x.
Divide by 2.
Divide by 2 gives me what?
5 pi over 6 plus pi n.
There you go. That's the trick right there. And you'll notice, yeah, in that thing, this has been squished, right? That's a compression. And so now the new period, we already found it. Oh, we had it up there. The period is actually pi. So this, by the time you get down to here, you're just doing this rote, you know, like, okay, now I do this, now I do this, now I do this. Now you can check your work and say, well, wait a second. Is the period of this thing actually pi? Oh yeah, it actually is. Nice. So then the other one, in a similar way, you'll end up getting, let's see, 11 pi over 6 plus 3 pi over 6 is 14 pi over 6.
Which is 7 pi over
7
3.
pi over 3.
7 pi over 3. We divide it by 2. You'll end up with 7 pi over 6 plus pi. Then you just got to figure out which ones are these. But you won't have to do that on the test. I'm just going to have you do one full period, okay? And it won't be too hard once you get down to here, right? And if this kind of freaks you out, then you could just use you don't really have to do this, because you could say, well, hold up, 7 pi over 6 is somewhere over here, it looks like, right? The smallest one of these I could get, let's see, 5 pi over 6. Actually, that might be 5 pi over 6 right there. No, 5 pi over 6 is on this side of pi, isn't it?
Yeah. Because the 6 is bigger than 5.
Okay, so then this one must be the 5 pi over 6. Right? Now, 7 pi over 6 minus pi, because the n could be a negative number, right? We're going in this direction now. That would have to be pi over 6. This one would have to be negative pi over 6. But again,
Wait.
it's now up to you to figure out how to learn this. I'm sorry. But it shouldn't be too hard to make up stuff and make sure that you can do it. This is, we're playing big boy math now, okay? Like, this is kind of a test of me and you. I want to see how well this works. If I give you this much information, you know, how well can you figure it out on your own? If that just bombs and everybody, whatever, don't worry about it. Don't worry about your grade. Just try to puzzle this stuff out. And you have more than enough, because like, you have about 1,000 of these in, like, that you've done on homework, right? You could easily take any one of them, see if you could figure this out where those zeros should be, and then graph it and see, does it actually work? If I plug in a pi over 6 right here, do I get a 0 out? Let's just see. Because that was my guess, and I might have done it wrong, actually. I mean, I very well easily could have done this wrong. So let's see if I did. I'm going to plug in pi over 6.
Wait. Oh, so it's...
So that's pi over 3 minus pi over 2. 2 sine pi over 3 minus pi over 2 plus 1. What's pi over 3 minus pi over 2? Well, let's see. We need a common denominator, so how about 2 pi over 6
Negative pi over 6.
minus 3 pi over 6 is negative pi over 6.
Sine of negative pi over 6 is 1/2. Negative 1/2?
It should be negative 1/2.
Yeah.
So 2 times negative 1/2 plus 1.
Is
Negative 1
Yeah.
plus 1.
0.
0.
All right? So it shouldn't be too hard for you, but this is the kind of stuff that, especially if you're going on in math, this is about, and like in college, what I've done right now is about what you'll get, and then you'll have to go puzzle that out. So this is an exercise for that, for you. Like, let's just try it, see how well or how poorly you do, and we'll figure out from there. Don't worry too much about it. Like I said, the one the one that I give you where you are gonna have to find this on the quiz will not be this bad, okay? It'll be more like the one just before that. So, real quick, now that people are coming in, let's try to get, what were your questions? What questions did you have from the homeworks?
Oh, the duck one.
The duck one.
I also did the mountain one.
The mountain
I think
one?
I did the
I
mountain one
thought
right.
I did the mountain one right, but I got like values right.
I'm pretty sure I did it. No, I'm not. I might not.
The duck one, you just have to like walk off miles per hour. And just like pretend they're like length. And then like somehow it works. But I don't think that's what you're supposed to do it.
But I don't know. I had no idea.
But they didn't really give me much.
Yeah. Yep. Yeah. Was the duck one the one where you had to have two equations and then?
What was the one, you put up the two triangles on the board, but I didn't see how that applied to me.
It was the cube one. Because you had to like.
Wait, the pyramid?
No, the cube one. Yeah.
Yeah, what cube? Number
Wait.
43.
Which cube?
It's the cube.
Was there a story?
No, it's just the cube, and you have to find like the
Here's
length
your
of
keys.
one corner to the
Perfect.
other corner. I think.
I don't remember doing that.
It was number
So wait,
43.
we got mountain, ducks, or
Wait, which
what
was
else?
the cube one?
The building one I
cube one
got.
was that one.
Did I not do that? Oh, I must have.
Well, you're gonna not get points then, are you?
What? That's not.
So do we want duck or mountain? Duck. Okay. It says we got the ducks. And they're moving.
43?
I'm terrible at drawing ducks.
Yeah, you don't really need to draw a duck. It moves from point A
I did 45 instead of 43.
to point B. Tough.
Wait, what was 45?
45 doesn't matter. I don't care. And we have a point O. And if you measure the angle, we want to know what angle? Phi. Here's your duck. That's not bad. That's not bad. The duck. So we know that the duck moves. It says that the duck moves from A to B. Video game. Duck moves from A to B
7 centimeters
at
per second.
7 centimeters per second.
Hard to say.
7 centimeters per second. The projectile fires at 25 centimeters per second.
Problem is there's no time, so how do you get there?
Yeah, and so the question is, when or at what angle should you fire so that when you first see the duck, you fire and we want it to hit, but we want to know where do you do it. Obviously, if you're aiming right here and you fire as soon as the duck shows up, he will have moved by the time.
Yeah.
If you aim way over here, you're probably going to miss the duck, right? So there's some sweet spot right there. So now let's think about this.
Sounds like a fun game. Sort of. Not.
So one thing to think about is, let's say that some amount of time has gone by.
Okay.
Let's just call it t. Let's say, so you fire at t equals 0, and then after t seconds have gone by, then it's traveled enough to hit. Okay?
Wait.
And so let's think about this. Because we have, because what we want is a distance. If we could actually figure out where this thing goes, then we'll have two distances, right? We'll have centimeters. So you have some number of seconds, we're not quite sure what, that will actually make this thing work, okay? So let's just call it t seconds. Goes by. We don't know what t is. But we might not need it. We might need it, we might not. So t seconds goes by, and now the duck is at where? Well, if he's going 7 centimeters per second times t seconds, he's at 70 centimeters. Okay? So if we're thinking about this as like an axis, he's at 70 centimeters.
So
Where's the projectile? Well, he's gone a total of what? If he's going 25 centimeters per second, and he's going a total of t seconds, he's at 25 t centimeters. Right? So a total of, so this length you could think of as 25t.
Oh. Yeah. That's what I did, except I didn't read.
so then sine of phi equals
And so now we have a triangle. And we're assuming that we got it right. Whatever it happened to be, that this all matches up and they both end up here. We don't know what time it is. We don't know what angle it is. But whatever that time is, we know that this distance is 7t. We know that this distance is 25t.
Sine of
And so sine of what equals what?
phi equals 7t over 25t.
7t over 25t. And like I said, maybe we don't need to know what t is exactly. They cancel, don't they? 7 over 25. And so what do I need to do to find theta, or phi?
arc sine.
Arc sine gives me phi.
So how,
Arc sine 7 over 25. Now let's just stop real quick. Is that a valid input?
Yes, 'cause
Are you sure?
it's less than 1.
It's less than 1, okay? So that's gonna give you some angle. Let's think, and now let's just analyze this and see if our answer makes any sense. You plug in something less than 1, 7 over 25. You get an angle that's between 0 and pi over 2. This angle should be between 0 and pi over 2, because obviously you don't want to aim that way. You'll just, you won't hit the duck, right? So this actually makes sense, right, that phi should be some angle between 0 and pi over 2 somewhere. That should be it. Pretty cool, huh?
So
I love
do
that.
one on
That's why I assigned that one. I love that one. All right.
so the t is, you have to set t to like be like correct time.
Yeah. But the cool thing is that you don't need to know what it is. Now that we have all of this, we could figure out what t has to be. Could we?
Yeah.
Maybe, probably. I don't know. Who cares?
Yeah.
It's actually it won't matter. It could be. And you notice how they didn't give you a distance?
Yeah.
Because it doesn't matter, right?
Yeah.
It doesn't matter how big or how much you shrink this triangle. It should be that. In other words, t doesn't matter. That's just cool. I like that. Want to do another one real quick? Mountain.
Mountain one was kind of fun, but hard.
Mountain one was very hard. Where was the mountain?
It's like
Oh, man. There it is. Okay, mountain. I love the mountain. How are we doing? How's
the
this
building
look?
one was also
That looks hard.
2 buildings was also
The 2 buildings was hard. But I gave you the answer.
Wait, you did?
I totally did. I just changed the tangents
Oh.
in class. I just changed them to 5 and 3.
I missed that.
And I even said, like, I even had it up there. It was like, you know, let's say that 5 equals d minus 50 or h minus 50 over d. And I said, now pretend that this says, oh, I don't know, tangent something.
Oh.
I gave you the answer. So watch the video. That's the best way of doing that one. This one. Okay, so we have a tunnel for a new highway that's to be cut through a mountain of height 260 feet.
Did they want the length of the tunnel under the mountain or the length of the entire tunnel?
So here's the mountain.
It's basically the length of the mountain is what you're
Yeah,
trying.
like the base of the
The base of the mountain is what we want. It tells us that this distance here, so there's a mountain. This distance is 200. This distance is 150. This angle is 47 degrees. This angle,
31.
36. And we know that the height of this mountain is 260. The height is, I'm going to write it like this, 260. You'll notice that the height for this triangle is the same as the height for that triangle. That's nifty. So here's the thing. this is what we need to find. Let's call it D, or distance. That's the distance we're supposed to find. Is there anything else there that I've missed? I don't think so. It says approximate the length of the tunnel, D, okay? So, what I notice is I could relate this and this, right? And the idea is, I know I want to use this somehow. If I could get 260 and this thing, so let's call this base B, and let's call this base, how about C? Okay. And it turns out that B plus C, this is what I love about drawing this, it's starting to come out as I'm doing this. It turns out that that distance, B plus C, is the same thing as that plus that plus that. So in other words, the total distance, B plus C, is the same as 200 plus D plus 150. Or I could simplify that and say, let's add those guys together. So how about 350? Everybody got that? Right? That total distance is 350 plus D. Okay? Okay, now forget about that stuff. We'll come back, like we have something involving D. Maybe if we get the rest of this stuff, it'll work. Well, C, this right here, whatever C is, it has this property. So then, tangent of this, and I'm just thinking what trig function relates that and those sides? Well, tan does. So how about 260 over C? I get C by itself, because now my goal is if I could get C as a number, and if I could get B as a number, then I have no more variables and I can get D all by itself. And so I'm going to redo this. Yeah? Ditto over here. Now we just have another triangle. Also has a height of 260. That total length is B. 36. Again, I could say what relates that and that. I guess it's tan. Tan 36 is 260 over B. Multiply both sides. We get this 260 over tan 36. Now, I have my C, I have my B, let's put them in here. My B is 260 over tan 36. C is 260 over tan 47 equals 350 plus D, so let's subtract off the 350. There you go.
And that's
Plug that in a calculator, you can approximate that bad boy. Are we good?
Yeah.
All right. Any other questions?